The next skill we're going to look at is dealing with an ambiguous case. An ambiguous case is a situation where, given a certain piece of information, I might be able to come up with one or multiple answers. I'm not quite sure which one they're looking for, so it's kind of fuzzy. That's what they mean by ambiguous, meaning we'll get more than one solution. So just as a quick review, there are a couple things that you learned in geometry about proving congruence. 5 ways you could do it. Side, 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 angle, side, angle, side, angle, side, angle, angle, side, and hypotenuse, leg. However, there were 2 situations we couldn't use to prove congruence. The first one is angle, angle, angle. And what angle, angle, angle gave us was that we had 2 similar triangles. We knew all 3 angles were identical, but we knew nothing about side length. So we knew that they were going to be similar triangles, but we couldn't prove congruence with them. The second situation was a side-side angle situation, or an angle-side-side situation. And the reason we couldn't prove congruence with that is we could come up with potentially 2 triangles. So a couple of facts we're going to keep in mind as we go through this ambiguous case. The sum of the interior angles of a triangle is always going to be 180 degrees. The second thing, no triangle can have 2 obtuse angles. The sine function has a range of -1 to 1, and when sine is positive, it can be in the first or the second quadrant. And that last piece there is why we sometimes come up with 2 triangles. A given sine value could appear in the first or the second quadrant, so it sort of makes things a little more difficult. So the situation that I want to begin by looking at is the ambiguous case for an obtuse angle. So as I've already said, ambiguous case means we can have 0, 1, or 2 possible solutions given 2 sides of a triangle and an angle opposite one of them. So this is specifically going to be your side-side angle situation. So if we're given an obtuse angle, only 2 things can happen. We could have 0 or 1 possible solutions. And for those of you who are visual people, here's the 2 situations we could come up with. I might give you an angle here that's obtuse. And let's say I give you a length for side A, and I give you side B. The situation could be that side A is not long enough to complete the triangle. So this would be 0 solutions. And that 0 solution situation occurs when the longest side is not across from the largest angle. When the longest side is not across from the largest angle. Sort of like the check we did before where the largest angle is across from the longest side, the smallest angle is across from the smallest side, and the middle angle is across from the middle length side. If we're given an angle measurement that's obtuse, and then the same variable for the side, which is the same as the angle, is not the largest value, I can't complete the triangle. So that's the 0 solutions. Or the other solution that does work, given an obtuse angle, the side across from it, A would be the longest side. Or if this was angle C, then C would be across from the longest side. If that's the case, I can solve the obtuse angle situation. So with example 3 here, A equals 98 degrees, side A equals 10, and B equals 3. So right off the bat, before I do any work, I can see, is it possible for me to solve this triangle? And the reason I can do that is I'm given an obtuse angle, 98 degrees. Since this is an obtuse angle, I've got one of 2 situations, 0 or 1. And I look at my side length for A. Is it the largest side that I am given? And the answer is yes. If I draw this picture out, and this is not going to be drawn to scale, but if this is ABC, this would be side B, which is 3, side A, which is 98, or angle A, which is 98, and side A, which is 10. I can see that just out of those three pieces of information, the longest side is across from the largest angle. So now I can use the law of sines to solve this oblique triangle. The first thing I have to solve is side B, because I'm given side B. So we'll start with sine of A over A equals sine of B over B. So the sine of 98 over 10 is equal to the sine of B over 3. Cross multiply and then take sine inverse, and I'll get that angle B is 17.282 degrees. Now that I've got angle B, I can solve angle C. Angle C, we know, is going to be 180 minus angle A minus angle B. So 180 minus 98 minus 17.282. So angle C then will be 64.718 degrees. So angle C here is going to be 64.718. Angle B is 17.282. The final piece then is I can find side C. Side C is the last piece I'm looking for. I should label that right there. So sine of A over A equals sine of C over C. And once again, I'm going back to the sine of A over A because those are my two sides where I've got exact answers for both the angle and the side length. So the sine of 98 degrees over 10 is equal to the sine of 64.718 over C. We'll cross multiply, divide by sine of 98, and we get side C is 9.131 units. 9.131. And doing a quick check, I've got my largest angle across from the largest side, smallest angles across from the smallest side, and the medium-sized angles across from the medium length side. So it looks like I solved that triangle properly. The last example is also an obtuse angle situation. And if I try and draw this guy out, we've got side A as 121 degrees, side B, or angle A is 121 degrees, side B is 19, and here I've got side A is 15. Here I can see the longest side is not across from the obtuse angle. Now you might say, well, why can't this be the largest angle across from the largest side? And remember, with a triangle, it can only add up to 180 degrees. I've already used up 121 degrees. So that means I've only got 59 degrees remaining between these two angles to work with. So it's impossible for this angle over here, which would be angle B, to be larger than angle A. I'd have more than 180 degrees. And that goes also to the definition that an obtuse, or a triangle, can only have one obtuse angle in it. If you don't remember that, you can always solve it mathematically. That if I do the sine of A over A equals the sine of B over B, I'll get the sine of 121 degrees over 15 is equal to the sine of B over 19. We'll solve this out. 19 times the sine of 121 degrees over 15 is equal to the sine of B. We'll take the sine inverse, and this expression right here simplifies down to 1.086. And you know that the sine inverse, you can't input a number that is larger than 1 or less than -1. So right here, you'll get no solution. You'll get a domain error if you plug it into your calculator. So if you don't remember the rule that the largest side has to be across from the obtuse angle, you can always do the math and you'll see that you'll get a domain error, which means no solution if you try to use the law of sines.